This is SABIS grade 10. This is term 3, week 5, and try to do it in the fastest way possible with explaining everything. Which of the following are examples of endothermic processes? We have explained last time what is the difference between the endothermic and exothermic. Just to memorize the examples, heating carbon with water to form hydrogen gas and melting an ice cube. If you want, this is a big list which contains all the exothermic and endothermic actions which we might encounter. The negative delta H is exothermic heat lost from the system. Examples are changing anything from liquid to solid or gas to liquid, freezing and condensation. This is the particle that's making the liquid that's condensed to form solids, or the gas is coming close together to form liquid. So you are making bonds between them. That's why it's exothermic. We know that bendo, mexo. So whenever you make bond, make is exothermic. The combustion is anything which has combustion or burning or heat is bring in is heat is coming out is exothermic. So if you said heat produced or combustion or fuel or methanol or release heat, this is all exothermic. Endothermic will be the opposite, solid into liquid. The solid is melting and the particles are getting far from each other. You are breaking the bond, so bendo. B is endothermic. Remember, bendo mexo. B, which is breaking, is endothermic, and M, which is making, is exothermic. So S into L into G, or S into G is a sublimation directly, also is an example for the endothermic. Dissolving NH4Cl in water, you have to memorize this one. Neutralization reaction, interaction between an acid and base will be an exothermic reaction. You have to memorize this one. The reaction between carbon and hydrogen form and water form hydrogen. This is called heating. Whenever you see the word heating or added heat or raising or doing any addition of heat, it is endothermic. If we see a reaction in which he said the temperature has increased, you know it is exothermic. If he said the temperature has fallen, it is endothermic. This is the second question, is choose the correct answer to complete the following sentence. The change in heat content is symbolized by delta H, while the heat content from the last time it was the H itself. So Hess law states that heat evolved or absorbed is not important. You go from A to B or A to C to B. So it's not important. It's independent. The path is not important. The most important thing is that you start from the same place and you end in the same place. So the initial reactants is important and the final products are important, but the path itself, it's independent of the path followed. You don't care about which path did you take, this one or this one. And most students forget this part. This is very important, the physical states. So if you started here with a gas, the other equation that you use will be a gas also. If you started here with ended with a gas, it has to be a gas also. This is very important, the definition of the Hess law. Independent of the path followed and depends only on the initial reactants and final products and on their states. Don't forget, this part is important. The question which is heading to most of the students, what happened here? What happened here is very easy. You multiplied the first one, you divided the first one by 2 and reversed it. And the second one, you don't change anything about it. So NO plus O3 give us NO2 plus O2. Why did you not do anything? Because in this equation, which is equation number 2 and this is equation number 1, we want to change them when we add them into equation number 3. So when you add see this equation, NO here did not change, so it is still the same like NO, and NO2 here is the same, not changed. So look at the direction of the molecules. Did anything change? It was in the reactants becoming the products, or it is the same? If it is the same direction, then don't do anything. If it is opposite direction, then change the plus into minus and the minus into plus, and then see the number of moles. So if here is NO and here 2NO multiplied by 2. If here is NO and here is half NO, so divided by 2. So here is the same number of moles and the same direction, so no change. The value is still minus 122 kilojoules. What about the first one? The first one is a little bit difficult. You have to think. In the final equation, in the first equation, I have O3 here, but I don't have, and in the second one, I have O3 here, but I don't have O3 in the last equation. This means that the O3s has these two has to cancel with each other, and the only way for them to cancel each other is to be on opposite directions. You cannot be both on the reactants, so you have to reverse one of them. We agree that this one will not reverse it, so we have to reverse the first one. If you put the 3O2 here in the reactants and the 2O3 in the products, now it is reversed. Now, when you add this equation to equation number 2, so this is equation number 1, when you add it to NO plus O3 plus 3O2 give us 2NO3 plus O2, you can cancel this one with this one because they are now in opposite direction. But still, you cannot cancel them because here is 2 and here is 1. So you must divide this by 1. What you will do? You will divide this by 1. This is what you'll do. So again, let's look at the two equations. The first equation, you have to reverse it, and divide it by 2, because when you reverse it, it will be like that, 3 over 2 over 2. So 3O2 in the products, put it in the reactants, and then divide it by 2. You will see now why. It forms 2O3. When you divide 2O3 by 2, it becomes O3. Why did you do that? Because in the second equation, there is O3 here. Now these two will be cancelled together, and you don't see O3 on the last equation. Here, this one will be reversed also, so it will become 3 over 2 O2. So 3 over 2 actually, 3 over 2 O2 is basically 1.5 O2. So if you have 1.5, so this is a half, and this is a half, and this is a half, and this is 2 halves, 1 in other side of the equation, you can cancel these two together and you will have half here. So this one is basically 3 over 2 is 1.5 O2. Why I'm saying this one? Because if you keep adding the equations, it will show up like that. So let's keep adding the equations. You said the first one, you will reverse it and divide it by 2. So reverse it, 2O3 will become on the products 2 over 3 divided by 2 removed. This one will become on the reactant side, so become O2, and then 3 over 2, which we said is equal to 1.5 O2. Let's see the second equation. You did not do anything. You put the reactants together. So how do you add the two equations? You put the reactants together. So this is the first reactant after reversing, and the reactants of the second equation is NO plus O3. We said that O3 will cancel out. We'll see it how. And then on the product side, there is NO2 and O2. We said that the O3 will cancel with the O3, and O2 and 1.5 O2. This is 1 and 1.5. We said 1 and 1.5. Cancel this one from here and cancel this one here. And on the left side remains half only. So this one is canceled and this one half only. So look at this one. Does it look like the third equation? Yes. So NO plus half O2 give you NO2. So this means that you divided the first one by 2 and reverse it. So it becomes minus 427 plus 427 divided by 2. You will get the value of plus 213.5. The second one, you don't do anything about it, minus 122. When you add them together, you get 91.5. Don't forget the positive sign. You get the positive sign and 3 significance. The next equation, what is the definition of calorimetry measurement of the reaction heats? And the last equation, is the Q is equal to what? Equal to C delta T, and the delta H is equal to C multiplied delta T over N. So let's try to tell you what is everything of this. So Q over N. Q is the total amount of heat, but he doesn't want Q. He wants it per mole, the amount of heat released per mole. So that's delta H. So we have to find the Q and then divide it by the number of moles. I will tell you how. The Q is C. C is the heat capacity. How do you find heat capacity in the equation? Look for this sentence always. The change in temperature, particular temperature, calorimeter, and water is contains. There is water here, so it's C capital. There is no need for the mass. I will tell you in other examples why there is mass. Here it's equal to 5, so put 5. And the change of temperature is 5. This is just a coincidence. 5 multiplied by 5 is 25. And then you try to find the number of moles. Number of moles is equal to mass over molar mass. What is the mass of the something burnt? That's 7 grams. Its molar mass is 28, so 7 over 28 is 0.25. Divide the 25 over the 0.25, you get minus 100. Where did this minus come from? This is a combustion reaction, so the equation has to be negative C delta T. It never comes out with positive, so don't forget to put the negative here and put 1 dot, because if you don't put 1 dot, you will get one significant figures. Remember the difference between these three numbers. You don't write it like that because this will be one significant figure. You don't write it like that because it will be 4. Just write it like that. It will be 3 significant figures. This one is easy. The CO reverse it here because here it's in the products, here it's in the reactants. So reverse it, it will become plus 110 instead of minus 110. And this one is the same, no changes. So it stays as minus 393. Again, you will add them like you added these two together. Again, you will add them after changing. So it will be minus 803 and 3 significant figures. This is 3 significant figures. This equation asking from the last time asking you to change it from the fractions into whole numbers, we have to multiply this one by 2 to get rid of it. So multiply all the equation by 2. Even the delta H will be multiplied by 2. So it's negative 220. And he asking you to incorporate this number inside the equation. Take care of this point. Very important point. When you want to incorporate in your equation, you have to put the delta H, change it from the negative into the positive. So outside, if he said delta H is equal to minus 335, but when you put it inside the equation, you put it as plus 335. And where do you put it? You put it in the products. If the reaction is exothermic, use this value, you put it with the products. If it is endo, put it with the reactant. So here I will put minus 220, change it into plus 220. Why? Because you will incorporate it. What about the endo? Endo is plus anyway. So put it here in the products and will be plus 220. The next equation is easy from the last time, just reverse it, and the minus 297 will be plus 297 because it is reversed. This one is very easy, reverse it, A plus B give us C, so reverse into C, A plus B into C, C gives us A plus B, and the X will change into negative X. This is two reactions. Make sure that you memorize this very well. The exothermic reaction and the endothermic reaction. The exo, you had 200 dirhams or dollars, and then you have 100. Why? Because you lost money. So you lost. So the amount of money in your pocket now is less than the beginning. The amount of heat or energy in the products is less than in the reactants. Is less than that in the reactants. And here, what do you say? The opposite. The endo. You had at the beginning $200 and now you have 400. Why? Because you added. So there is a positive increase. Here there is a negative increase. There is loss. You came down. You become 200 after 400. Now you become 400 after 200. So there is gain of energy. It's plus. So this is the shape of the exothermic. Always know how to know it, and that products is less than reactants. Here products is more than reactants. This is positive and gain. So don't forget the bendo mixo. As we said, energy is released when bonds are formed. Energy is absorbed when bonds break. And B is endo. So if you break this bond between two carbon atoms, breaking means endothermic reaction. You absorb heat. You break this bond between them. If you make a new bond between them, then you are making bond making. So it is exo, which means you release heat. Thank you so much. Always look for more videos by subscribing, and you can log into k-chemistry.com to see a lot of nice things in the SABIS syllabus. See you.